Okay, hey everyone. My name is Vinny, and I'm at the team at Chef Robotics. Today I'm going to talk a bit about getting robots to place food like people. Let's dive into it. So a quick agenda, kind of just going to give you an overview of Chef, what we do, the market we aim to serve, kind of go a bit deeper into our product, and then kind of go into the challenge of placing food specifically. All right, so what is Chef? People ask me a lot of different things. They'll be like, are you making robots for the fast casual restaurants that we all know and love? Or better yet, they'll be like, do you make robots that I can take home and help make dinner for me? And the answer is, not yet. Chef actually started out doing fast casual. This is one of our earlier prototypes, 2 6-off arms. And we had commercial interest from a salad restaurant chain. And we got a lot of learnings from doing this. One of the things is that using a single utensil for a wide array of ingredients is difficult for multiple reasons. One, because one tool is not the best for every ingredient, but also different portion weights, allergens. Here's a visualization of what that looks like. For those of you that might notice, this is a web viz from 2020. So at Chef, we've been using Foxglove before it was Foxglove. But one of the other things we noticed is that the worker usually assembling food in one of these facilities is not just doing that task. They often ring up the customer, they'll do food prep in the kitchen, they're doing inventory, they're cleaning things up. So the unit economics become a bit tricky because you got to get the fractional cost of labor that's spent at that counter below what it costs them today. And so with that learning, we decided to move more towards prepared meals. So what are those meals? I'm sure some of you guys have seen these salad kits at Trader Joe's, or the bistro, the fridge section at Starbucks, or even the frozen dinners that you'd find at most department stores. And if you were anything like me, 4 years ago when I joined Chef, having watched things like how it's made, you would imagine that all this stuff is made in a way that's something like this, where it's like a symphony of stainless steel machinery working together to just automate every part of it until it shows up on the grocery store shelf in front of you. But after joining Chef and taking a peek behind the curtain, I was kind of shocked to learn that most of the stuff is still being done by hand. And you're probably gonna ask, why on earth are we still doing this by hand? And the reason is because hard automation just doesn't work when you have the slightest variation. So if you're assembling a can of soup that you make millions of units for, you can get dispensers that do that 1/4 of an inch cooked spaghetti pasta, put the soup base in, place into a very specific target, and every single piece of it can be hard-coded. As soon as you have a bit of variation, a little bit slower, a little bit faster, a different ingredient type, a different placement type, this all breaks down. So humans have just been a better option here. And this sector is really chronically understaffed, as the slide shows. I've had the pleasure of going to 6 or 7 of these facilities, and I can understand why. Essentially, you're standing in one place for 8 to 12 hours a day, standing upright, picking and placing in a repetitive motion. And to add to that, some of these facilities operate at 36, 33 degrees Fahrenheit, right above 0°C. So you gotta wear snow gear, but you also have to have the dexterity in your hands, so you can't wear really thick gloves. And so my fingers would go numb after an hour of standing there. And so often doing rideshare or working in a fulfillment center is usually a better job for the same pay. And so this has been quite a challenge. I'm sure some of you have seen these on packaging of food that you've eaten. This is usually a hint that you're probably consuming something that was made in a high-mix facility and on shared equipment. All right, so food, it's one of the biggest markets in the world. Labor is also one of the biggest markets in the world. The intersection of the two, it's a growing problem. We estimate that about 3.1 million vacancies will be there in the United States for work like this in 2030, which is only 5 years away. And there are other headwinds that are kind of approaching, which are a rise in prepared meals. Other forms of prepared meals, I'm sure some of you have gotten these ads in your social media feeds of these prepared meal services that kind of make chef-curated entrees. They're shipped straight to your door and with freezer packs. So this is also a sector that's using similar sorts of labor, and this is a growing demand sector. And of course, some of you, like myself, are guilty of DoorDashing or Uber Eatsing way too much. And increasingly, production from those facilities are also happening what we now call ghost kitchens. So that's another angle to which this is increasing. So Chef's kind of focus is to kind of nail this kind of high volume, but still sort of diverse food manufacturing take the learnings from autonomy, from the food safety cases, really being on the floor, gathering production data, and take those learnings to go more and more custom at lower volume until we get to that place where we're like in the back kitchen of a restaurant you like or in your home. So here's our V3 system. It is the most widely deployed version of our product today. There are 4 robots on a line. Each of them are picking up a different ingredient. And you can see here that like they're always operating with a conveyor belt in view. And to kind of give you an overview of our product, one of the things I'd like to highlight is that every single hardware component, except for 2 things, are off the shelf. So our focus is really on the autonomy side. But the 2 parts are the stainless frame that encloses the entire system, but also this whole family of custom utensils to manipulate a very broad range of ingredients in a very reliable way for weight targets and placement. But we're trying to build out that ecosystem through learning and playing with the food so that our end-of-arm tool is just really able to scale for mass mix. So I kind of want to focus more on the placing side today. I think any of you that have worked in manipulation can appreciate the fact that grasping and deforming food is hard. Deforming body simulation is still an area of research. But I think unintuitively placing seems really, really easy. Humans just like take it and dump it. But I want to show you why it's a bit hard to get robots to generally do this. So we operate on a lot of different conveyor belts. Some of them are textured, some of them are flat, some of them are waxy. You'll see this sort of like kind of artificial blue color a lot in some of these facilities. The reason for that is because you don't really see this particular pigment of blue occurring naturally in food. So it's easy to discern if something breaks off or falls into the food that's being made. And it's not just flat belts. We're working with odd geometries. This is like on the left here. One of our customers has 2 stainless bars that sit higher than the base belt of the conveyor, and they have these strange plastic inserts, so it's kind of confusing to fit a plane to that. On the rightmost, it's almost hollow. The bowls actually fit into these slots, and the top rim of the bowl actually sits at the base of the conveyor. And then you're also dealing with different obstructions. So this middle image here, it's a pull cord that workers can use to stop the line, if they want to take a break or something happens. It's easy for a human arm to just avoid that, but we got to ensure our cobot doesn't smack into that and bring down the production line. And it's not just that. We have a lot of different ways to place. This is just like a small snippet of the kind of placement requirements we have to hit. And some of these targets are really, really small, like half the size of a Post-it. And so you want to really make sure you get in there without spilling, but at the same time, you don't want to hit the rim of the bowl, hit the conveyor, so the target can be really small. And yes, that's a piece of flatbread. Some of these applications also require us to not just place in bowls, but also types of food like pizza crust, tortillas. So that's another area of exploration. And so a lot of these are not perfectly rotationally symmetric. So orientation actually matters a lot, which gets me into our annotation. Our bounding boxes need to be really, really flush. So if we're off by 5 millimeters, we may hit the rim of the bowl. And so we do a lot of data gathering. That flywheel is in process. And we're constantly collecting data from not just a particular bowl, but particular bowl, different robots positioned on different parts of the line to really get that lighting diversity. And also, you don't want to overfit the food that's present in the bowl. So you got to get samples with like different ingredients, so the detectors don't latch onto some corn or beans. We actually, because the annotation task is so broad, we use tools like off-the-shelf grounding dyno to get us zero-shot bounding boxes, as well as using SAM and SAM2 to get an estimation of angle. So we've added angle to our detectors to get oriented bounding boxes. One of the other challenges here is like we gotta, some of these facilities, we only learned this after going there, they have slanted floors ever so slightly to allow liquids to drain out into vents on the floor. And this causes slight tilts, like the conveyor is sometimes tilted a little in X or a little in Y, and the robots themselves might be sitting on a drain a little bit lopsided. So these are all like subtle details we have to take into account, otherwise we can't place with that really tight tolerance. Here's another application of us placing into 4 lanes. This is a frozen Indian entree manufacturer, and humans may like reach far out, use their hips. You can see the arms here, kind of angling the tool out so they don't hit singularities, but are still able to do wide coverage. Here's one of those robots through a Foxglove view, one of our many beautiful Foxglove layouts. You can see that each track is being individually maintained. The green targets signal which tracks the robot is going after. And then we also have to do speed estimation to be able to handle things like the belt decelerating, accelerating, And we still, as you see here, the bowls slow down and the robot's still able to place in static bowls. All right, so I want to really zoom into one specific complexity. If any of you have worked in manufacturing, you can know it's all about throughput, so just trying to crank out as many units as possible. And so oftentimes, this is one example of that, where two workers are placing the same ingredient, but they're switching off so they can keep up. In even more sophisticated facilities, sometimes they're doing 120 units a minute, and they have like 4 or 6 workers trying to keep up. And so this seems pretty easy. It's pretty easy for humans to discern which one's served and which one's not served. But as I'll show you, it gets a bit hard for robots. So we started out with per ingredient classifiers, simple binary classifiers. Is the food there? Is it not there? The issue is that this becomes bespoke to a particular ingredient in a particular meal, in a particular setting. So this is like corn and peas on a meatloaf meal for one of our customers. And with Chef, we really focused on getting onto production, so this immediately kind of broke. To date, Chef has done over 65 million servings of food in production. So we've seen a lot of different combinations of ingredients and a lot of different scenes. So we couldn't create a bespoke classifier for every single use case. And so we took efforts to generalize. Like, what can we do? What can we take from literature? And so we took a look at similarity networks, technologies like Siamese neural networks, which are used by things like Face ID on your iPhone, or plagiarism detectors. And we were wondering if we can extract features from the scene to be able to determine whether the food is present or not. And so we converted some of these papers to actually take the imagery from the pan and compare it to see if the ingredient we were intending to pick is already present. And this actually worked. Here's a reduced dimensionality plot of the feature space, and you can see there's 2 clusters here. On the left, there's bowls that already have the food in it, along with some of those pan images. And then on the right, you have some of the empty bowls. Here's another example of that, and I'll zoom it in a bit so you can see what's actually in there. This is a pesto tortellini meal, and you can see the very clean split, being able to determine whether there is pasta or not pasta in that bowl. And so while this did work, and it worked quite well for certain ingredients, it wasn't quite enough, because we need to hit 4 nines, which is like 1 in 10,000 mistakes, across tens of thousands of permutations of ingredients layered upon other ingredients, right? So if you have like carrots on a rice base versus carrots on another ingredient, this doesn't generalize too well in that long tail. So this is an example with corn and black beans on salsa, which the model is still able to do, but you can imagine things like Parmesan on Alfredo pasta. It's really hard, even with a high-resolution camera, to really pick that up. And humans can really easily just pick up on the glisten of the sauce or some other attribute, which is harder for a robot to tell. So we went a bit deeper and we're like, okay, what else can we do? And we tried experimenting with adding features to the conveyor to help the robots localize and split the task. But Chef's thesis is to really, really be low integration. You just wheel the robot in. It should be a one-to-one equivalent with a human. And so it was a tall order asking some of these customers to integrate a multicolored belt for us to be able to start working with them. So we ditched that idea. We tried going with offset bowls. So we just asked, hey, workers, can you just put one closer, put one further, and on the robot, when you set up, you just say which lane you want it to serve. And this did work, as you can see in this footage, but the workers absolutely hated this. We suddenly added complexity and cognitive load to like an otherwise simple task. If you're a worker just kind of doing that all day, now you have to think about like switching every time you serve. And we listened to the feedback, we went back to the drawing board and started working on alternatives immediately. And so we kind of asked, what if the robots coordinated? What if they teamed up together to kind of share some information? And then we kind of took that further and like, what would they share if they did share information? And a lot of these potential things that we could use kind of had the same sort of issues where the long tail would probably fail. We even considered having the leader robot, push the bowl that it finished serving so the other robot knows to skip it. But ultimately, we ended up using a very simple method. Essentially, there's always a time when the first robot doesn't have bowls in front of it. So there's a gap before it gets that first train of bowls. And you can see here, this is the first robot on a line. It starts by serving every other bowl. And what we did was we extended the memory, and so it continues to keep state of where those tracks are. It's measuring the speed of the conveyor belt and imagining where they're going to be. And what we did was we sent this information to the robot further down the line. So the next robot, as it gets the same bowls, it's able to kind of do an estimation in X of the distance between the two robots and serve the inverse of the tracks that were already done. And as you can imagine, there are like gotchas with this, but this did actually work. And with a little bit of support, a little bit of training, we have served millions of bowls in this manner. Here's the actual UX of that. And we essentially have the user go up, select pairing almost like you're connecting to Wi-Fi. The robots beside it tell you what serial number they are, and you just input that into any of the 3 systems. And now they're all streaming that data over a local mesh. And they also know their ordinal on the line, so they know which tracks to send to which robot. And to kind of an evolution of this, while this was all going on, our perception team began working on a segmentation model that was meant to be a single model that could generalize across all ingredients. And it's a neural network that takes a before and an after image of us serving food and generates a pixel mask of what food was placed. And the goal with that is, to kind of score our own placement, of course, to offer as a QA product to customers, but more importantly, that the robot can eventually self-correct and have a signal to improve its own poor placement autonomously. And so we're seeing promise here with this potentially being a good feature extractor to take these images and actually find the nuanced features that tell the difference between a bowl that has food and it doesn't have food in it. And we're actively running inference on every serving in production. Every single before and after image is captured and uploaded to the cloud. And we're having humans do review of the quality of these masks. All right, so I'll wrap up the placement talk there. I just want to tell a little bit more about Chef. We're based here in San Francisco, Potrero Hill, for those of you that are familiar with neighborhoods. We have a 22,000 square foot facility, which includes manufacturing space. We actually assemble these robots here in SF and then ship them all over the continent. And we have a team with a broad range of autonomy experience and also hardware experience. Some photos of our facility. This is part of our manufacturing and testing area in Potrero Hill. We have a lot of fridges to store a lot of ingredient we get from our customers. We recently added this walk-in fridge. And then, of course, lots of space to test. And then lastly, crates, because we are in production. We really care about shipping. So we made these custom crates to help make the process smoother. With that, I'll do the same plug everyone else has been doing. We are hiring. And so if you found any of this remotely interesting or you know someone who does, please reach out. I have some of my teammates here as well. We're hiring across engineering and go-to-market. So yeah, love to hear from some of you, but thank you so much.